In this video, we are going to talk about what is ant colony optimization algorithm. How can we apply this probabilistic technique for solving computational problems to a real-world problem like solving a maze? Most people would say it's very easy to solve a maze problem and it's particularly designed for a kid. Let's take a look at this small maze. It's very simple for one to get from the start to the end without taking a wrong turn or find the dead end. But what if you have a bigger and bigger maze like this with more than one possible solution path? How can we solve it? Or how can we find the shortest path through a complex maze with multiple possible routes from start to finish? Before we answer these questions, let's understand what is ant colony optimization. What is ant colony optimization? Most ants have poor eyesight. Some species are completely blind. However, ants are social creatures, and they are united strongly. Question: how do they social? Let's see some basic facts about ant colony optimization. Ants deposit pheromones on ground that form a trail. The trail attracts other ants. Ants can figure out the short path according to concentration of pheromones. How can they do that? Assume there is an obstacle. In the beginning, it's 50% chance that an ant in front of the obstacle will go the upper side with distance d. Another 50% chance the ant will go lower side with distance 2d. Let's say it takes the ant 1 second to complete d distance. If the pheromone remains there as it for 1 second, after 1 second, it becomes 1/2 in the next second. Then, it will become 1/4 in the next second and so on. After 1 second, assume the upper path has pheromone of 100 units, whereas the lower path has 50 units only. The concentration of pheromone in upper path will keep increasing, so the probability of going upper path is increasing, and the probability of going lower path is decreasing. After some seconds, all ants will follow the upper path. Then, the short path has been found. This idea works for different maps. The same optimization will be realized in this map. The shortest path will be found eventually due to the pheromone distribution. This explains the basic idea of ant colony optimization. Now, you knew what is ant colony optimization. Let's go back to our project. From this point, we'll be covering the goal, implementations, and conclusion of this project. Our goal is to find the shortest path through a complex maze with multiple possible routes from start to finish. This issue is called NP-complete problem. What is NP-complete problems? It is a decision problem we can solve easily. We could verify a solution even though it's sometimes difficult to check. How can we solve this? Yes, ant colony optimization algorithm. We learned that ECE is originally aimed to solve the traveling salesman problem. The problem is to find the shortest tour through a series of cities, starting at some city and going through all other cities once and only once, and returning to the starting city. So, we think it's a good idea to use ECE along with our modified DFS algorithms to solve a maze problem. Here is 5 steps of the implementation. Maze generation. The first step to solving this problem came in generating some data to use for training and testing the design system. We designed the maze through use of a node graph. It was mandatory that the generated maze had to include multiple possible routes from start to finish. The general layout for all node graph mazes in the shape is a square with only a single entrance and exit position. Ant program driver, running the program with different settings, modeling the results, and evaluating them allows for discovery of optimal settings to solve mazes of different sizes. Number of paths through the maze found per generation, each path being an ant, size of the maze, in number of nodes per one side of the square maze, number of ants selected from each generation to lay pheromones down, pheromone evaporation rate, etc. Modified depth first search. We created a modified depth first search algorithm to find the exit. Since there could be more than one possible path an ant can go, We use the roulette wheel concept of ant colony optimization to help an ant picking the direction. For example, if there are two options to move to next, one with 8 pheromones and the other with 2, the paths have an 80% and 20% chance of being chosen, respectively. Laying down pheromones. We developed the laying down pheromones algorithm to help ants drop number of pheromones appropriately. For example, if ants were to lay down pheromones again over sections where it had to backtrack, the entrance to this dead-end corridor would have twice as many pheromones on it as the eventual correct path to the exit. Then, future ants that come to the same node will be more likely to go towards the dead end, which is clearly not the shortest path. Displaying maze results. To visibly depict how the algorithm advanced, there was a need to design a system to display the maze, as well which paths were taken by the various ants each generation. The larger weights or dark red shade represented paths with higher pheromone deposits, thus attracting more ants along the specified path, and the green line represent the best solution on each generation. Now, you see how the ants solve the short path of the maze automatically. Let's summarize our project briefly. First, we use a maze generator to generate a maze. Then, let the ants enter the maze. At the beginning, ants go everywhere, exploring, and drop pheromones. However, pheromones distribute differently among the maze. After a while, more ants picking the direction with more pheromones when making movement decisions. All that explains how the ants find the short way out of the maze. Things were not very easy in the beginning because we don't know some questions, such as, how many ants should we put into the maze? What will happen if the pheromones evaporate faster? These questions led to long time for the ant to explore, or sometimes, they can't find the shortest way. So, we did statistics to find better parameters for the optimization. These parameters gives us smarter ants. Thank you for watching.